So I've spent most of this day, this Sunday, from like 5 in the morning till just recently, like a couple of minutes ago, playing with Rust, that programming language Rust, and playing with the thought of starting a new, what's the thing called? A new series where we learn Rust instead of C++ because of reasons, okay? And I even made 2 videos. And I have another third one right here ready to go and be edited. But I decided, after a little bit of deliberation and working on it for pretty much all day, 3 videos worth of, at least, while I was recording the 4th video, I was like, nah, we're going to stick with C++. Because you know what? C++ is old. Everybody has learned. Everybody that's been doing this knows C++. And there we go. We're not going to get into Rust at the moment. Okay, we're going to do this C++, and then we'll go to Rust later. So yeah, not that that's really a big change, but there we go. That's what I've been up to. That being said, let's run this thing. And we can see it's doing this again as usual, but the thing does work as usual. All right. The thing about that though, get out of here, is this window while open and this SF rectangle shape and render window and all this stuff. Okay. This stuff, using these libraries, this stuff right here, this is I don't know how to explain it. I'm kind of tired too. This stuff right here is, the big boys don't do this. The big boys do something else. Like Blizzard and all that. What they do is they go directly to Windows. Show us the C++ that would open up a window in a blank window in Windows, an empty window, window in Windows. Enter. All right. So to create that, we would have to get this windows.h. Okay. That's the first thing. We have to connect to the Windows API. And then we would do this lresult callback, blah, blah, blah. And this is whatever code to get Windows. It's the C++ to get Windows to just open up a window. While using the library over here, it's literally just this right here, and it opens up a window. Okay. This and this, I guess, or something. Anyway, it's a little more simple than all of this right here. All right. But the thing is, Blizzard and EA and all the big guys, they're using this somewhere in their code. They're not using Jimmy's library. You know what I'm saying? They're using their own library and their own tools, unless it's like a third-party tool that they just do not care to create. Like, I don't know, maybe like audio processing tools and stuff like that. You know, they'll use the third party for that. Anyway, that being said, we're going to do this. Okay, we're going to do this, and we're going to start that right now. So let's start up a new chat. Let's link our files yet again. All right. So these 3, these 2. Okay. With these C++ files, I want to make it to where we make our own library that can do the window display and color choices and whatever, so we can can do in-house stuff like Blizzard and the AAA companies do. Where would we start? Where would we start? Question mark. Graphics library. I like that. For our window display and color choices in C++, similar to what large game companies like Blizzard do, we can start by expanding on the structure we already have in our C++ project. Here's a step-by-step approach to get started. Identify core requirements. Window handling, of course. Rendering, yes. Input management, yes. Color management, yes. That's all the stuff I actually wanted to do. I want to know how to do this stuff directly with whatever, you know? So choose the right tools. SFML, which we're already using, great for 2D games. Look, if Blizzard doesn't use SFML, neither will we. For production code, pardon me. For production, neither will we. We have the time to build this stuff, especially since it's all well documented. All right. Got it. We're looking to build a custom graphics library from scratch. Here's how we can start. Focus on a low-level approach similar to major development companies, whatever. Language and environment setup. C++ solid choice. Setup development environment with a compiler that supports this or later. We've already got that. Graphics API. Choose a graphics API for low-level graphics programming. Vulkan. So does SFML deal with a graphics API in itself? Question mark. Yes. Specifically OpenGL. Okay. So they use OpenGL somehow. But we're going to use Vulkan. All right. Okay. Vulkan is a powerful choice for cross-platform graphics and compute operations, though it's complex and has a steep learning curve. We got time. DirectX on Windows or Metal on this are alternatives. We're not doing that. All right. Learning curve. Prepare for significant learning phase if we opt for Vulkan due to its verbose and explicit nature. We're going to have to deal with it, right? This is like the real crappy, dirty reality of programming. You know, we could go on top of the highest level and go get Unity and Unreal and go in an Unreal Engine and go create, you know, games like that. We could. We're not going to. No, we're starting from a place that's modern yet DIY. I don't know how to say it. Anyway, this is what you get. You get what we're doing. All right. So this Windows system interface will need to handle the window on the context in which our graphics will enter. This an SDO. Okay, so does Blizzard use GLFW? Question mark. I think this thing is like really wanting to custom built. Look, custom what? Okay, we need custom built everything. Okay? Everything from scratch. Do you get it? Okay? Okay. Core system, Windows management. Yes, that's what I wanted to do. Okay. Build a system to handle window creation, resizing, and closing events. This is foundational as it will serve as the main interface between our application and the operating system. Perfect. Graphics rendering, renderer. Develop a renderer that can handle drawing primitives to the screen. This involves managing graphic buffers, shaders, and rendering pipelines. We're going to need to do this. Graphics API. Directly use low-level API like Vulkan for complete control over graphics rendering, or develop our own abstraction layer over Vulkan for more flexibility. We'll figure it out. Input management. Create a system to handle user inputs from keyboards, mice, and potentially gamepads. That's okay, cool. This will involve capturing and responding to events and managing input states. Yes, cool. There we go. Resource management. Develop a way to load, manage, and unload various resources such as textures, models, and shaders. Yes. Efficient resource management is critical for performance. Audio systems. Implement an audio system to handle sound playback, audio effects, and possibly 3D audio for more immersive experience. Physics and collision. If our game requires physical interactions, we'll need a physics engine for things like collision detection and response, physics, simulation, etc. Okay. Game logic. Create a framework for game-specific logic, including scene management, game object management, scripting, and event handling. This is going to be so much. This is so much. Networking. For multiplayer components, implement networking capabilities to handle communication between clients and servers. Okay. Tools and editors. Build tools for asset creation and editing, like level editors and animation tools, which can significantly speed up development and allow for easier content creation. Debugging and profiling tools. Develop tools to help with debugging and optimizing our game. This might include performance profilers, debug overlays, and log systems. Building each of these components from scratch will give us maximum control over the functionality and performance of our game engine. It's a challenging and time-consuming process, but can be very rewarding in terms of learning and customization. We have to do it. We have to do it. This is what we have to do. Okay. Could we do it high level? Yes, we could absolutely do it high level. We could definitely do it high level. But I don't care about making games as much as I care about making games. I don't care about the games as much as I care about the making of the games. You know what I'm saying? Because the games themselves, they're already made. Matching games are already made. Shooters are already made. Top-down league-style games are already made. Like, coming up with something new, whatever. You know, let somebody that's really, really into that get into that. I want to make the game itself. Like, from nothing to something. You know what I'm saying? And we don't want to sit around and be slave to Blizzard and Epic and all these other companies. Why? When we can make our own. You know what I'm saying? It'll take time, but whatever. We got time. All right, so let's do it. All right, first step, core system. Okay, so let's do the core system. I'm going to delete all the SFML crap and turn it back into a console game. Console checkers match. Let's do that right now, actually. I don't even need to tell it that. So let's get all this junk out of here. Let's get all this out of here. It worked. We know it worked. We know we were able to make a board with pieces, but we weren't able to do it without a library that we don't want. And so here we go. Save it. Let's run it. Come on. Yeah, no. All right. What? Let's go to Git. Let's go to view branch history. No, let's go to master. Huh? What? What is this crap? All right. Oh my God. Get manage branches. Master. Continue checkout. Cool. All right. Run it. This should run, right? No. Z. Control Z. Get. Manage branches. Master. Reset. Delete changes. Yes. Have it outside the reload. Whatever. Is this it? Is this the one? Run it. Okay, good. I was about to die. Not really, but you know. All right, so there we are. We're back to square one. We're back to this place. Save it. All right, let's go to. Let's give it to ChatGPT. All right, where are you at, ChatGPT? Okay, here's the files now. Files now after reverting them. Where are you at? Right here through here. All right. Let's make a window to display this board. Finally. All right. That's what I was looking for. Is there really just no way to just do this without the graphics thing too? Or we have to use this? All right. So we're going to have to set up this Vulkan stuff. I mean, we're going to have to, so we're going to do it. Set up the Vulkan instance. Okay, let's look up setting up Vulkan in C++. Okay, sure. Maybe that'll work. Install the Vulkan SDK from this website. Run the installer and do the instructions. Okay, so let's go to Vulkan from LunarG website. Vulkan SDK. They both look good. This one looks like they're getting charged though, so let's use this one. All right. This looks like what we want. Let's go to Vulkan. Let's go to the front page. Whew. They don't care. These guys, this is a professional website. They don't care if we know how to use it or not. They're not even trying to tell us. There's some docs. All right. Give me a second. Oh my goodness. It's just one thing after another. How long? How long till we can get something on the screen? This is nothing like free code camp. This is what they were talking about. This is real coding. You have to be looking up crap all the time. Linking one thing to another and whatever. Oh. This is going to be a 20-minute video because I am tired of doing this. I think I'm going to go like exercise or something. My body feels crappy. I've been working in a chair all day on a Sunday. And so, yeah, that's going to be it for right now. We're going to come back to this Vulkan SDK introduction on the next one. We're going to read through this, get the thing on the internet. I mean, get the thing working on our in C++. Then we'll go for there. This is already looking crazy. All right, so we'll do that, and we'll see you next time.